Hey guys, it's Miss Carney here. In this unit, we've been working on relating fractions, decimals, and percents. In our most recent lesson by Ms. Pahatsky, we were working on using the strategies of 10% and 1% to find the percent of a number. This week, we're going to be working on using two more strategies to find the percent of a number. We're going to start off with a little bit of a review though from last week. Lauren bought a jacket that was on sale for 60% off. She paid 40% of the original price of $75. How much did Lauren pay for the jacket? Well, the first thing I'm thinking is, wow, 60% off? That's a big sale. This must be like the end of the season or something, because whenever I'm shopping, I can usually get a 30 or 40% off deal, but 60%, that's more than half off. It says that the original jacket was $75. $75 represents 100%. This is the whole. In the problem, I see that Lauren paid 40% of the original price, because if you take 60% off of 100%, that means what you're paying is 40%. So this is your original price minus your discount. Whoops, spelled that wrong. And that equals what you pay. So for Lauren, if you're finding 40% of the original price, we can think back to last week. What strategy would you use here? That's right. You could find 10% of the original price and then do that 4 times, or 4 times 10%. 10% of $75 is $7.50. 40% is going to be $7.50 times 4. Sorry, not $7.50%, 50 cents. $7.50 times 4 is $30. So 40% of $75 is $30. And that's just using those strategies from last week. Lauren paid $30. So let's think a little bit more about what makes sense. When you're finding the percent of a number, how can you tell whether or not your answer is reasonable? Will the answer be greater than or less than the original amount? Well, you've got to think back to the lesson on percents greater than 100 and percents that are less than 1. If you have a percent greater than 100, then your final answer is going to be more than what you started with. But nobody who has any sense is going to pay more than 100% of a jacket when you're shopping. So you wouldn't expect to pay more than $75 for the jacket that was originally priced that way. Now, if you're taking a percent that's less than 100, like 60% of the original price, you would expect to pay less than $75. And I'm thinking that 40% is a little bit less than half. So if I think, what is half of 75? That's like $37. So the jacket should be a little bit less than that, because 40% is less than half. So you can use estimating strategies to see if your answer is reasonable or if it makes sense. Let's talk a little bit more about estimating, looking at this first example. Estimate and find percent. The 4th, 5th, and 6th graders at Great Oak School are taking a field trip. Of the 575 students attending the field trip, how many are 6th graders? Okay, well, I see here that 6th grade is 36%, 5th grade is 40%, and 4th grade is 24%. I'm going to estimate here. 575 total students, and the whole graph adds up to 100. What numbers could I work with that are easier? Well, 36%, that's about a third. 40%, that's kind of close to half, and 24%, that's close to a fourth. And yes, 1/3 is a fraction, and so is 1/4, but we know that fractions, decimals, and percents are related. So when our numbers are compatible, we can use the fraction form of the percent. I'm also going to think about this 575 as, there's about 600 students there, because that's an easier number for me to work with. I can use a double number line to think about this. When I'm estimating that there are 600 total students and that 1/3 of them are 6th graders, because 36% is approximately equal to 1/3, I can think, all right, 200 students, 400 students, 600 students is my whole, and that's 1/3, 2/3, or in 3/3, or 100%. So about 200 6th graders, or 1/3 of the total, are attending the trip. Another strategy is to use a calculator to find the exact answer. I remember from previous lessons that the decimal form of 36% is 36 hundredths. And remember, when you say the number out loud, 36 hundredths, that helps you to know what the decimal equivalent is. 36% is 36 out of 100, or 36 hundredths. When I change it to the decimal, 36 hundredths times 575 is 207. So 207, that's pretty close to what I estimated over here of 200, and I know that my answer is reasonable. All right, let's think 68% of the students attending the field trip are boys. How can you use the double number line above to find the number of boys and to check whether your answer is reasonable? Well, I'm just thinking about reasonable. I don't need to know exact. And I'm thinking to myself that 68% is pretty close to 2/3. Because I can think 66 and 6/10 repeating percent is 2/3. And these numbers are pretty compatible. So if I'm going to look back up at the double number line, 2/3 of that 600 total is 400. So there are about 400 boys on the field trip. So I kind of mentioned this before. If you're finding the percent of the number, when would you want to use the fraction form instead of the decimal form? And this is going to be in a situation where it's easier to use the compatible number, knowing that 2/3 very easily works with the number 600, or maybe in another situation if you were working with 25% and you know that 1/4 and 25% are equivalent, and it's easier for you to maybe say take 1/4 of 100 than it is for you to multiply that by 25 hundredths. So the answer to this one is when the numbers are compatible. All right, so first we were talking about estimating to find percent and thinking about what's reasonable and thinking about what's compatible, using fractions to do this or using decimal equivalencies. Now the other two pieces to lesson 6.5 are finding the part and finding the percent. And these are demonstrated in the two examples. I want you to remember those phrases. Find the part, find the percent. Those are going to be the most important parts of this lesson. I'm looking again at another double number line diagram where we're looking at the percent and then we're looking at a value. In this situation, Dwayne plans to wallpaper 72.5% of a 60 square foot wall. How many square feet of the wall does Dwayne plan to wallpaper? Find 72.5% of 60. Okay. So it's telling me to write an equation. To write an equation, I've got to think back to earlier in the year when we talked about English to math translation. For me, the easiest way to do this is to take the words from the problem and then literally write the mathematical symbols just below those. So if the problem is asking me to find 72.5% of 60, of 60 is. So I can't use the percent form. I'm going to change this to the decimal form. 725 thousandths. The word of means to multiply. I remember this from earlier in the school year. 725 thousandths of 60 is, I remember that the symbol is, or is represents the symbol equals, and then unknown, because I don't know what the answer is yet. When I multiply 725 thousandths times 60, that's 43 and a half. I look back on the problem, 43 and a half what? Oh, I'm talking about Dwayne and I'm talking about wallpapering. This is 43 and a half square feet of wallpaper that Dwayne needs for his house. So let's write these words down. We have of, which means to multiply. We have is, which is going to be our equal sign. And then we have what, or find, and that's going to represent our unknown, which I'm going to be using the variable x for. Let's try this example. What, okay, what does what? That's going to be x. Is, that's our equal sign. Now, this is 0.8%. This is a really small number. So think 0.8%. Move my decimal 2 places to the left. This is 8 thousandths. Then we have the word of, that means to multiply, and 35. Now I can solve. 8 thousandths times 35. I'm going to use my calculator for this. That is 28 hundredths. So the value of x is 28 hundredths. Okay, so that was finding the part. Now we're going to look at finding the percent. What percent of 92 is 11.5? We're working again with writing equations, and we're still thinking about that English to math translation. What percent of 92 is 11.5? I'm going to rewrite that over here. What percent of 92 is 11.5? Okay. What percent, what is variable x of, let's multiply 92 is equals an 11.5. Oh, hey, I've written an equation. Can I dig way back to a few months ago when we were solving equations? If I have x times 92 on the left side of the equal sign, how do I undo that? What's the inverse of x times 92? That's right. I'm going to have to divide both sides by 92 to isolate the variable. If I divide this side by 92 and the right side by 92, do you remember when we had 92 divided by 92 and that equals 1? Do you remember putting the slash through those to represent that? So now I know that x is equal to 11.5 divided by 92, which is actually right over here, and that's going to be 125 thousandths. This is something you can use your calculator for. 11.5 divided by 92 equals 125 thousandths. Now 125 thousandths, I've got to change that to the percent form for my answer, which is 12.5%. All right, that wraps up the examples for now. Tune into the next video where we take a little bit more time to work on find the part and find the percent. We'll start with this try it example at the bottom, but if you'd like to go ahead and try that on your own before you tune into the next video, then you can check and see how you are understanding. See you soon.